Let's look at another cyclic structure, another ring structure. I'm going to look at my ring. I see 1, 2, 3, 4, 5 carbon atoms. Because I have 5 carbon atoms, and because it's a ring structure, I'm going to have the name cyclopent, and I've got all single bonds, so I have the A and E ending, and that's going to be the base name of my molecule. Now what I need to look at is see which atoms are included in that cyclopentane and which atoms are not. The atoms that are not included are my substituent groups, and those are the ones that I'm going to have to name in the molecule before I name the cyclopentane. So I have 3 of them. Now when I look at the ring structure, now I've got to figure out where to start counting. And what I want to do is I know that no matter what, the first substituent group is always going to be carbon 1. So with ring structures, especially when I have multiple substituents, I have to count a couple of different ways, more than we do from left to right and right to left, because we can determine where our 1 atom is. So I'm going to show here in red, I'm going to start counting here 1, 2, 3, 4, and 5. I could also count counter or clockwise with, I'm going to show this in blue, 1, 2, 3, 4, and 5. But I can also start counting from these other numbers. I'm going to pull in a new color here. Now, what if I start counting here at this chlorine and I go 1, 2, 3, 4, 5. Or I could start counting from that same carbon atom, but count in a different direction and count counterclockwise. So I get 1, 2, 3, 4, and 5. So what we see is that when we have ring structures and multiple substituents, there's a lot more ways to count those atoms. Now, we could also start with our chlorine up here as substituent 1 and count around. Because of this molecule, I'm going to see that I'm not going to get anything different, so I'm not going to show that here because we got enough colors and numbers here to confuse us all, so we're not going to add more, but we could count from that one as well if it would think it would get a smaller number. So you kind of have to do some trial and error to figure out which groups are going to give you the smallest numbers. So what I'm going to do is I'm going to go through here and I'm going to look first at my red numbers. And if I look at the red numbers, what I see is that I have substituent groups at 1, 3, and 4. If I look at the blue atoms, I see that I have substituents at 1, 3, and 4. So it didn't really matter which way I counted. I ended up with the same number. Sometimes that happens, sometimes it doesn't. It depends on the number of carbons in the molecule and the way the substituent groups are arranged with respect to one another. For these kind of orange, peachy colored numbers, I see I have substituents at 1, 2, and 4. And if I look at my purple numbers, what I see is that I have substituent groups at 1, 3, and 5. So what I want to do is I want to try to decide which of these is going to be the best choice for numbering. Now, because it's a ring, my first substituent group is always going to be at number 1. So that really doesn't help me decide which kind of way to number the molecule, because I know I'm always going to have a number 1 whenever I have more than one substituent in a ring, or even when I only have one substituent. So I know I'm going to have a number of 1. So what I have to do then is look at the next substituent group. And what I see is that if I looked at the numbers in red, the second substituent is carbon 3. For blue, the second substituent is carbon 3. For the peach, it's at carbon 2. And for the purple, it's carbon 3. And so what I see is that if I use these numbers here in orange, I get the lowest set of numbers because it's always going to be 1 for the first one, but now my second number is lower. Now there are some cases where the second number is also the same and you actually have to go to the third number to decide which of those is going to be the better pathway. So now that I know where my groups are located, I know I have chloro groups. I have 3 chloro groups, so I can actually assemble the name of my molecule now. I have 1, 2, 4. Since I have 3 chloros, I'm going to say trichloro because I don't want to say chloro. And it's a cyclopentane. So chlorocyanide. cyclopentane. So that gives us the name of the molecule for the ring, and it deals with the fact that we have many, many ways sometimes to count those ring structures to determine what the best set of numbers in, because we're always going to have one at carbon 1.